Assalamu alaikum. Dear students, let's move to the next part of chemical kinetics. In this part, we'll discuss about the other factor, that is temperature, which affects the rate of chemical reaction. That is temperature dependence of rate of a reaction. And in that, we'll be discussing about Arrhenius equation. Now, as we have discussed till now, the concentration factor in these previous sessions, whatever we have discussed, that was all based on the concentration, how concentration affects the rate of chemical reaction, right? So we have seen different ordered reactions, how they are related with rate. Okay, now we'll go to the next factor which affects the rate of chemical reaction is temperature. As we know that whenever you heat up a reaction, दैट टाइम व्हाट हैपेंस इट स्पीड्स अप. जब भी आप कोई रिएक्शन को हीट करते हैं, नॉर्मली लैब में अगर दो रिएक्टेंट मिक्स करने के बाद कुछ भी रिएक्शन नहीं हो रहा है तो हम क्या करते हैं, बर्नर के ऊपर हीट करते हैं ताकि रिएक्शन स्टार्ट हो जाए या फिर फास्ट हो जाए, राइट? तो इसका मतलब ये होता है कि टेम्परेचर बढ़ाने से रेट ऑफ केमिकल रिएक्शन बढ़ जाता है, रिएक्शन की स्पीड बढ़ जाती है, राइट? इससे क्या मालूम होता है? टेम्परेचर इज डायरेक्टली प्रोपोर्शनल टू द रेट ऑफ रिएक्शन, or rate of reaction is directly proportional to increase, that is temperature. Okay, only one chemical reaction or the biochemical reaction which is inversely proportional or not directly related with temperature is the enzymatic action. enzymatic reactions कैसे होते हैं? ऑप्टिमम टेम्परेचर 310 केल्विन पर मैक्सिमम उनकी एक्टिविटी होती है. टेम्परेचर या तो ज्यादा हो गया या फिर कम हो गया तो इनकी एक्टिविटी कम हो जाती है. लेकिन बाकी के जितने भी केमिकल रिएक्शंस हैं, दे आर डायरेक्टली प्रोपोर्शनल टू, their rate is directly proportional to temperature, right? So we can conclude that increase in temperature increases rate of chemical reaction. In general, we'll go almost all chemical reactions, their rate will increase with the increase in temperature. Okay, now by practical analysis, it also has been found out that with the rise of temperature by 10 degrees Celsius or 10 Kelvin, जब भी temperature 10 degrees Celsius or 10 Kelvin increase होता है, rate of chemical reaction gets almost doubled, right? Rate of chemical reaction क्या हो जाता है? Double हो जाता है. Say for example, if the rate was 1 mole per liter per second, okay, or 1 mole per second or per minute, when you increase the temperature by from 25 degrees Celsius to 35 degrees Celsius, the rate will become 2 mole per liter per second or 2 per second or per minute. मतलब डबल हो जाता है सिर्फ कितना टेम्परेचर बढ़ाने से? 10 केल्विन और 10 डिग्री सेल्सियस इंक्रीज करने से. मीन्स डिफरेंस इन टेम्परेचर शुड बी ऑफ 10, right? So that time what happens? The rate of reaction almost doubles, right? So that thing we give in the form of temperature coefficient of a reaction denoted by mu, right? So this change in rate of reaction by increase in temperature by 10 degrees Celsius or 10 Kelvin, it is given in the form of temperature coefficient of a reaction. Let's see what is this temperature coefficient of a reaction. It is the ratio of rate constants of a reaction at two different temperatures differing by 10 degrees Celsius or 10 Kelvin. What is this? It is the ratio of rate constants of a reaction at two different temperatures differing by 10 degrees Celsius or 10 Kelvin. आप रेशियो ले रहे हैं किसका? रेट कॉन्स्टेंट्स का, के वैल्यू का, राइट? रिमेंबर कॉन्सेंट्रेशन फैक्टर में हमने क्या देखा था? कॉन्सेंट्रेशन चेंज करने से रेट ऑफ रिएक्शन चेंज हो जाता है, लेकिन रेट कांस्टेंट वही रहता है. लेकिन यहां पर टेम्परेचर इफेक्ट की बात करेंगे तो टेम्परेचर फैक्टर क्या करता है? रेट ऑफ रिएक्शन को बढ़ाता है. टेम्परेचर चेंज करने से इवन रेट कांस्टेंट भी चेंज हो जाता है. मींस हियर विथ रेस्पेक्ट टू टेम्परेचर फैक्टर, रेट कांस्टेंट depends on temperature. Rate constant depends on temperature, where it was independent of concentration of the reactant. Concentration कुछ भी रहने दो, लेकिन rate constant temperature के ऊपर depend करेगा. अगर temperature बढ़ाएंगे तो rate constant भी change हो जाएगा, temperature कम करेंगे तो rate constant भी change हो जाएगा, right? So what we are taking? We are taking the ratio of two rate constants. How they are measured? At a normal temperature, and one more rate constant is measured at a temperature higher than the previous by 10 degrees Celsius or 10 Kelvin. Suppose ये rate constant आप 25 डिग्री सेल्सियस पे मेजर करें तो यहाँ पे क्या आएगा 25 डिग्री सेल्सियस प्लस 10, इट विल बिकम इक्वल टू 35 डिग्री सेल्सियस. तो जब आप ऐसे रेट कॉन्स्टेंट्स का रेशियो लेंगे, कैसे, एक रेट कॉन्स्टेंट हायर टेम्परेचर पे मेजर्ड है और एक रेट कॉन्स्टेंट लोअर टेम्परेचर पे मेजर्ड है, दोनों में टेम्परेचर डिफरेंस कितना होना है 10, तब आपको मिलता है वो रेशियो, दैट इज उस रेशियो को हम बोलते हैं टेम्परेचर कोएफिशिएंट, एंड इट इज ऑलवेज or almost equal to 2. Sometimes it may be 3, but most of the time it will be 2. Means uh, rate of a reaction almost doubles when the temperature is raised by or increased by 10 degrees Celsius or 10 Kelvin. Okay. Mu value stands for temperature coefficient. For almost all reactions, what will be its value? It will be equal to 2, because with the rise in temperature by 10 Kelvin or 10 degrees Celsius, rate of reaction almost doubles. Okay. This temperature dependence can also be explained very clearly and accurately by using an equation called as Arrhenius equation. This Arrhenius equation gives correct and accurate relationship between the rate constant and rate of reaction, and one more important term, activation energy and temperature of the reaction, right? So this Arrhenius equation will help us to relate temperature along with the rate of reaction. It is given by the equation K is equal to A e raised to minus EA by RT. What is the Arrhenius equation? K equal to A e raised to e to the power of minus EA by RT, where K is rate constant, A is called as Arrhenius factor or frequency factor or pre-exponential factor, R is gas constant, EA is activation energy in joule per mole, and T is temperature in Kelvin. This is called as Arrhenius equation. Many of the times in the examination they have asked for 1 mark, write the Arrhenius equation, or for 2 marks also write the Arrhenius equation and mention the terms involved. So you have to write the Arrhenius equation and you have to write what are these terms called as, right? So this Arrhenius equation will help us in relating rate constant, temperature, activation energy and rate of a reaction. Okay, so in next session we'll see using some diagrams, using some graph, how this temperature is related with rate constants. Okay.